Geophysical Method. What is geophysical methods? Geophysical methods are investigative techniques that assess the existence of resources or material behavior hidden underneath the Earth's surface as a result of geologic process or human disturbances, either directly or indirectly. Geophysical methods are useful to the following area: to detect subsurface contrasts including mass density relationships, ionic or electrical potentials, magnetic susceptibilities, and elements decay, to identify the location of archaeological resources, to investigate buried prehistoric and historic structures and artifacts. So there are types of geophysical methods: electrical resistivity methods, gravity geophysical methods, electromagnetic methods, regiometric methods, and seismic methods. Electrical resistivity method. Electrical resistivity methods are types of geophysical surveying that helps with the subsurface imaging. These methods rely on difference in the electric potentials to identify subsurface materials. It is based on the idea that the electrical potential distribution in the ground around current-carrying electrolytes is influenced by the electrical resistivities and distribution of soils and rocks around it. Types of electrical resistivity methods: vertical electrical sounding, electrical profiling, and electric imaging. Vertical electrical sounding, or VES. Vertical electrical sounding is a ID resistivity system that provides detailed subsurface information with little equipment and staff. It is one of the most oldest methods of determining resistivity, as well one of the most cost-effective per unit depth. For science surveying or when equipment is restricted, the VES method can be very useful since high resistivity companions are basis of with VES. Data from vertical electrical sounding are more resilient to electrical shocks than the data from the other magnetic methods. Electrical profiling. Electrical resistivity profiling is a two-dimensional resistivity technique in which a picture of the Earth is formed and electrical property are used to interpret various geological or hydrological conditions. To visually distinguish this situation, we use color contouring. By spatially extending information away from whole two-dimensional resistivity profiling may also be used to improve understanding of borehole data or assist in location of a new borehole electrically unusual areas. And next one is the electric imaging. Electric imaging is basically the combination of the other two electric resistivity methods. It is a non-destructive method for subsurface investigation. In this method, the electrical current is injected into the earth through a pair of current electrodes, and the potential difference is measured between a pair of potential electrodes. In most cases, the current and potential electrodes are arranged in linear series. The apparent resistivity is the sum of the resistivities of all subsurface materials that influence current flow. Gravity geophysical methods. The gravity method is non-invasive, non-destructive, remote sensing method that is relatively inexpensive. Subsurface geology is studied using gravity surveying, which uses change in the Earth's gravitational field caused by differences in density between the subsurface rocks. The notion of cohesive body, which is rock unit with a different density than its surroundings, under microgravity profiling. Microgravity profiling is a passive technique that involves measuring relative shifts in Earth's gravitational field with extreme precision. A gravimeter, which consists of a highly sensitive temperature stabilized spring balance, is used to take measurements. Since differences in the density of material inside the subsurface cause subtle changes in gravity, the method can be used effectively to identify voids of submerged features like underground storage tanks. Electromagnetic methods. It refers to methods that employ the theory of electromagnetic induction to excite electrical currents in the ground using a low-frequency, time-varying magnetic field as a source. These methods are sensitive to the electrical conductivity of the subsurface. Types of electrical resistivity methods: frequency domain EM, time domain EM, ground penetrating radar. Frequency domain EM. The frequency domain method relies on electromagnetic waves inducted on the subsurface to produce electrical currents in subsurface conductors. In geophysics, the term frequency domains EM, FDEM, and EM induction refers to geophysical investigation methods based on principles of induction as defined by Faraday's law. As much the EM induction umbrellas cover all methods that involve measuring voltages induced in the Earth when exposed to a varying magnetic field, either time or frequency domain. Time domain EM, a non-intrusive geophysical approach for collecting subsurface resistivity conductivity data, is the time domain electromagnetic method. Time domain electromagnetic method is useful tool for mapping changes in rock or soil, such as clay layers that limit groundwater flow, conductivity in groundwater, and seepage in earthen embankment. Ground penetrating radar. Ground penetrating radar works by sending beams of ultra-high frequency radio waves down into the ground through a transducer. The ground penetrating radar antenna is dragged along the ground by hand or by a vehicle or ATV. Various buried objects or distinct interactions between different Earth's material represents the transmitted energy. The reflected waves are then received by the antenna and stored in digital control unit. The signal is amplified after the control unit detects the reflection against the two-way travel time in nanoseconds. The digital control unit plots the output signal voltage, picks a different color bands in the ground penetrating radar profile. Next one is Regeometric Methods. The Regeometric or Gamma-ray Spectrometric method is a geophysical method for estimating potassium, uranium, and thorium concentration by calculating the gamma rays that these elements' radioactive isotopes emit during radioactive decay. By measuring gamma-ray radiation above the ground from low-flying aircraft or helicopters, airborne gamma-ray spectrometric surveys estimate radio element concentration in the Earth's surface. Seismic methods. The seismic methods assess the response of seismic waves that enter the Earth and then refract or bounce off subsurface soil and rocks boundaries. A sledgehammer strikes to a metal plate on the ground, a larger weight drop, or an earthquake are the most common source of seismic activity. Geophones which detect ground motion are used to calculate the Earth's reaction. So there are two types of seismic method: refraction method and reflection method. Seismic refraction methods. One of the few geophysical surveys that is most commonly conducted by engineers during investigation. It produces the most basic of geologic data by geologists or engineers through plain procedures with equipment. Refraction shock waves are deformed or refracted due to entering materials of various elasticity, like the way the light waves are deformed when passing to the water from air. Reflection shock waves are bouncing from surface of various media, like the way the light reflected from the mirror. Theory. The propagation of waves in elastic medium is the basis of seismic investigation. Homogeneous isotropic elastic media are considered as soil and rocks in theoretical circumstances. Any deviation from the isotropic condition in assumed homogeneous can be expanded to show changes in depth and nature of subsurface of geologic units. Seismic waves. It is any mechanical vibration that is commenced by a source and moves towards where the vibration is noted. The vibration emerges in all directions, thus the displacement is supported, and due to disturbance it is merely changed in the stress state. The vibration readily passes to the one another from medium, from solids to liquids or gases, and vice versa. There are two major classes of seismic waves: body waves and the surface waves. Body waves. Body waves passes through the volume of material or all media that carry noise and gases, including the atmosphere or air waves. They are called pressure or compressional or primary wave or P wave, which are the fastest traveling of all the seismic waves. Secondary, transverse or shear wave S wave moves slightly slower than P waves in solid. P waves can only travel to materials that has shear strength, therefore it do not exist in liquids and gases, as no shear strength is presented in the medias. S waves may be provided by source of traction or by convenience of P waves at the boundaries. Surface waves. Surface waves move slower than the body waves, thus these waves are reduced rapidly with distance from the surface. It is produced by explosions, subsurface impacts, waveform transformation at the boundaries. It exists only at surface or interfaces, that is the two perceived vibration, the love and the Rayleigh waves. These surface waves may have more energy composition than body waves, wherein it may cause more damage from the vibration an earthquake. Collecting of data. The production of better seismic equipment has been perennial to allow because of data electronics, wherein newer equipment is harder, more efficient, and able to store more amounts of data. Sophistication of survey partially manage the choice of equipment and the field crew size necessary to acquire the measurement, as the survey that is being initiated will be the basis of choice of equipment and source of seismic waves. Sources. The sources of seismic waves may be a hammer smacking the ground, or aluminum plate or weight plank shot from a rifle, harmonics, accelerator, or explosives. A geophysical contractor should be a given guide if the source of the task will be changed or selected, as he or she should be vigilant not to go beyond the requirements, permits, and other agreements. The portable seismic instrument, geophones. It is the sensor that receives the seismic energy. These sensors are either velocity transducers or accelerometers that transform ground movement into voltage. The profound value of particle cannot be determined unless geophones are regulated. Seismographs. It is the recorder of inputs of geophones voltages in sequence of time. An elaborate amalgam of equipment that sends or trigger the source, geophone signals, and other data is seismograph system. However, in engineering and environmental surveys, sophisticated seismograph equipment is not normally mandatory. Amplifier recorder. It is essential in electronic amplifying and timing devices. It amplifies the times of interval between shock and current generation of geophone due to the arrival of seismic waves in the minute electrical current received by it, having a frequency of 1000 cycles per second by an electrically driven tuning fork, which is the most time that the device recorded. Operation techniques. In seismic surveying, good operating techniques and correlation are essential if adequate field data are to be collected or interpretation. Geophones layout. Reverse seismic profiles are essential to acquire a factual picture of condition of the surface. Subsurface interfaces which are not parallel to the ground surface will construct apparent V2 and subsequent velocities which are greater or less than the material's true velocity. Energy sources, mechanical or explosive used in seismic survey. Mechanical energy sources slam directly upon to the ground surface using include 8 to 10 pound sledgehammer striking a plate or tumbler device. Which explosive energy source can be used to exquisite advantage where the signal's multiplication and noise levels required more energy than the mechanical energy provide. Geophone's location. The number position can either be geophone location or multiple channel system or hammer position for single channel systems. The different layouts given more or less definition in the required surface, regardless that there are changes of the end position for forward and reverse spreads, and the number and the spacing of position can be modified as required. Reflection. The reflection method determines how long it takes a sound impulse to move from its source, a bounce of a geologic boundary, and then return to the surface at a geophone. A geologic horizon reflection is similar to an echo of a cliff face. The angle of reflection from a surface equal to the angle of incidence in seismic reflection. According to the law of mirror images, shots are fired at each of geophone position in turn. An active geophone are inserted ahead of the shots and removed behind the shots in roll-along fashion.